Thank you for joining today. My name is Aman Tonk. I'm an Android engineer at PayPay India. Today, we will talk about WebViews, why people use WebViews, their pros and cons, then what server-driven UI is and how it can help. Next, we will see how Kotlin Multiplatform with Compose work for SDUI and see an example built over it. Last but not the least, we will discuss how we can scale the SDUI to production. Let's get started. So, what are WebViews? In simple words, WebViews are a small browser inside an app. It shows web pages or mini web app without leaving the native app. Every platform or OS have their own implementation of WebViews. By using the WebViews, the app can talk to web content, and this stays separate from the web browser of your device. So why we use WebViews? The main reason is speed. Features or change request ships instantly. You don't have to wait for a redeployment and app store reviews. They work across the platforms. You just need to write it once and show it anywhere you want. If there is already a web version of an app, what you need to do is just load that URL inside your native app, and it will just load inside your mobile app, and you will save some money as well. Thoughts? It sounds great, right? But let's see if this is really great. There are a few cons as well. WebViews feels slow. They use very high memory. Screen instantly can feel non-native. Even new users can spot a difference between a web screen and a native screen. WebView may not access device hardware-specific features like NFC and sensors. Debugging is also very hard when we use a mix of WebView and Kotlin native apps or Swift native apps. Let's address the elephant in the room, the security. Security is also a big concern here, especially for finance app like PayPay. WebViews face web attacks like cross-site scripting injections where data can be intercepted. To talk to native apps, WebView use JavaScript interfaces. They are useful for use cases, but they are risky as well. They are risky if the content is not safe. They are risky if the request to get the content is not being validated. Users just have to trust us as developers to keep them safe. But should they actually do it? Let's see an example. This is the warning sign we see as soon we enable JavaScript in WebView settings. The Android Studio shows us this warning. We are just tend to ignore this and go with the flow, like it doesn't really matter at all. So in long run, what I feel is WebView often add cost and bring problem as app grows. So they are not good long-term solutions. So what's the alternative? Let's discuss the alternative. In my opinion, as a native Android developer, native should be the first choice because they are smooth, they are modern, they are secure, they are more close to your OS. But the major advantage of WebView was to deliver dynamic content without redeploying the app to production and of course the App Store reviews as well. So if we want fast changes to the native UI as well, server-driven UI is a best option which I can think of. But SDUI, what's that? Let's see. In simple words, server-driven UI or SDUI is a setup where the server tells your app that what and how to display. Remember how here. The server sends instructions and your app just reads them, creates the UI, and render it on the screen. You can change most about the UI instantly from the server without redeploying the app to production and being reviewed by app stores. Simple, isn't it? But let me explain as well. Here are the core principles. Think of it like this. The server decides what to show, how to show, when to show, and what happens when user interacts with the UI. The app just follows the instructions from the server without asking any questions. This makes update easy, flexible, and bring the customization control to the server. On the app side, there will be a library of UI components. Like on app side, there will be a library of components like buttons, text, images. It depends what your product actually needs. If you are working for a media company, maybe you require a video player as well. It totally depends on the product. The server sends the instructions. The app maps the instructions to the UI components and renders to the screen. The server also tells what actions to take when user interacts with the components. Like when user taps on a button, the server will also decide previously with the server instructions. Here is a side-by-side comparison of WebViews, limitations, and SDUI benefits. SDUI reduces the big problem of WebViews. It's agile, updates are instant, security is stronger because everything is native. And the most important part is it is native. It's a great way to deliver dynamic content to apps in no time. Pretty cool, right? Let's see how you build this in practice. Today, we will use Kotlin Multiplatform to build a sample of SDUI framework. But why only Kotlin Multiplatform? Well, why not? For me, as an Android developer, Kotlin feels like home. And the best part is, it stays fully native. So you never lose the speed or feature you expect. At the same time, you can write important code once and share it across the platform. That means less time is spent recreating the same stuff for different devices, which is awesome if you are building something complex and challenging like an SDUI library. Kotlin Multiplatform and Compose Multiplatform is a powerful combo. You get to share both UI and logic with the native speed. The Compose Multiplatform is now stable enough to build with 100% confidence. And you can still add platform-specific APIs, maybe something for some platforms, when you need something special. Let's walk through the main architecture for our sample. Here is the simple flow, as I mentioned earlier, how SDUI works is the server sends the instructions. In our case, the instructions will be sent as JSON. The app uses Kotlin serialization library to parse them. The resolver resolves the data to UI components. Initial state will be created in State Manager. And the Compose will render the UI on any platform given to it. This is simple and efficient. Once the UI is shown, the user interactions will be handled as per instructions given by server. Some events can be handled locally, but other may talk to the server for next step. It totally depends on the server instructions. There won't be any app side logic. The only intelligence an app will have is to handle missing details by showing defaults UI, which makes it reliable even if the server fails to instruct. This way, the user experience stays smooth. Yeah, enough talking, yes. I'll show you some code as well, for sure. But I just need a second. You must be wondering what he is talking about. We are receiving the JSON from server till now and showing it on UI as our daily job. What we are actually discussing here, what's special with SDUI? Remember the stress I took on how? The secret is behind that stress, how keyword. How will you build the UI? So to simplify, first let's see what is not an SDUI. This is not an SDUI. This is what we do as a daily SOP. The normally app decides most of the layout by itself, and server sends the content. But in SDUI, the server actually decides the look, the feel, the order, and the size, including padding, style, and what happens when users interact. The app just follows those instructions and build the real native UI. Let's see how this same layout will look like when it will be built with an SDUI. This is how it will look like. This is an SDUI. I know that JSON grows in lines, but the plus point is that you can make quick changes to the designs and content right from the server, and you don't have to redeploy the app. Maybe something like this. The layout changes a lot without any redeployment. It depends how you are structuring your SDUI JSON or schema. Unless there is a new component required to support the UI, you don't have to redeploy at all. Cool. Let's go back to the code. Are you guys ready? Let's see some example code. Here are the DTOs, or data transfer objects. These are the building blocks for information pass between your server and app. Some parts are always needed, but others only require for certain components. This should stay flexible, so it will be easy to add new type later. Next, the app takes the JSON from server and turns it into those DTOs using Kotlin serialization for this sample. Along the way, add simple checks to make sure the data is exactly how the app expects. If something goes wrong, the app should show a fallback UI with reporting back to server instead of just crashing. For validations, we keep it simple. Just check if the incoming instructions are something the app supports. If not, decide whether to fill in with the default content or skip that piece on UI. The key is staying stable no matter what comes from the server. This is the entry point for our sample app. We call it SDUI main component. It takes the parse SDUI component from the DTO, which we have mapped from the JSON. From there, the whole screen will be built out. Here is the sample of simple text component example. The data has already passed through our validation layer, so we know it's safe to render. Now the app uses the mapped native widgets for this component type and bring it to life on screen. We have something called styling, or I should say dynamic styling. It is a major advantage with SDUI. In our sample code, it's being handled through a style JSON object, which will be sent from the server. It means everything about the UI, the look, the layout, the color, padding, margin, background, everything will be under server control. It makes it easy to keep everything consistent and flexible. The design system adapts to the screen of any size, and you are not logged into decision hard-coded in the app and then the requirement of a redeployment just because you want to change the text style or maybe text size. Let's see the actions, how the interactions, which will be used for interaction handling. Action defines what happens when a user interacts with your UI. Just like tapping a button, submitting a form, navigating to other screen. We use a sealed serializable action model in our sample. The server can send all sort of actions for navigation, API calls, updating states, showing toast, or even custom actions. Action can also be chained together. For example, a successful API response could immediately trigger navigation to another screen and maybe show a toast too. Now that we have seen how component, styling, actions work, let's bring it all together into a live demo. Let's build the sample code, which I prepared for this presentation, and see how it works. This is the sample code I built for KMM with CMP. Let me just run it. We will run the JVM version of it. As soon we run it, it's on my second screen, so we see something like this. This is the playground which I have built for this session. In this side, you see a JSON editor. Let me increase the font size a bit. Should be fine now. This is the JSON editor. This is not an emulator, but it looks like an emulator, but it's a composable, built-in Compose. And we have the logs viewer. There are some logs here. If you see this sample here, the root of the JSON have a key called type. This is the widget type. For now, it's row, but it can be either column or box. It maps to the Compose multiplatform for us. It totally depends how you have built your own SDUI library. Maybe you can call it linear layout or maybe you can call it frame layout. But for us to simplify mapping it with existing components of Compose, I have kept it similar. We have a row which have 4 children. Each of them are text. Consider this JSON as coming from server, and this is your mobile UI. So if you change something on this JSON, it will reflect like this. I know it's fast here, but when it will come from server, it should be changeable as well. Not this speedy, but it should be. Let me reset. Here we have row. As I mentioned, we support column. Here is a column. And then box. Let's reset it and see another example. This is very, very simple example. This is the simple form which I have built with just JSON here. And you can see the UI. We have column, which is the root component. Then we have children's. The first children is the text, which is simple form. You can see the styling, the size and the weight is coming from server. Let's say in future, if product team decides to increase the size of the font, you just have to change it from here. No need to deploy the app. Let me reset it to the initial one. Here we see a spacer, which works like a spacer in Compose. We have a text field. So the special thing about text field or any component which can take user inputs is that they need to save that input somewhere, which we can use later. I have used a required key for this, which is ID. I call it text field name. And then same for next text field, which is text field email. We have a placeholder as well for both of the text fields. Now here see the action. This is something which is pretty good here. The action is called API call. What we need to do is, once user have filled this form and click on submit, we need to upload this data to server with the given URL, method, headers, and body. Let's talk to them one by one. This is the URL where we want to just send the data. This is the method. These are the headers. One thing you should always remember with SDUI is that you have to follow the security protocols with SDUI. SDUI meant for UI. You should not send sensitive data to the SDUI. So here, the auth token will use a environment variable stored on your app side, which is your app auth token. So when these headers will be used in actual API call, this will be replaced with the actual authentication header. Then we have body. So body is like, it's referring to the states. This key is the same key which I have used here and here as well. Here we are uploading the data as body. And then we have configured deep links when the API call success or fails. This is a bit complex, but once you build your own SDUI from scratch, and when you are building it, you will understand it more better. Let's see a simple layout. Simple layout, but with nesting. Till now, we have seen row and column without any nested layouts. But in this case, we have a column where we have a text. Here we have another text, and then row, then spacer, then buttons, and the card. Card is a special which I have added for this demo. You can add as many as components you want in your own library. This is just for sample purpose. This JSONs create this UI. Let's see the last one. This I created for DroidKaigi 2025. This is how it looks like, almost like a sample app. This names as DroidKaigi Gallery. Here we see 2025 DroidKaigi banner on the top, and then pictures from previous year DroidKaigi. One thing just to tell you again, this is not an emulator, this is a composable, and you see the UI correctly here. Let's see the JSON line by line. We have a column, which is the root component. Then we have the alignment, which is center by default in my library, but for this I have configured to start. Then we have a row, which is this row, DroidKaigi text and search icon. Then we have a spacer, then image, a spacer again. Then we have text, which is 2024, which is the last year. Then we have another row. See this? Scrollable, true. In my sample, I have configured if the scrollable true is coming from server, I will use lazy row, else I will just use row. You can configure whatever you want in your own SDUI library, but this shows the true potential of an SDUI framework. We have 4 images, which we can see here. Everything is changeable from server. So for an example, if you want to remove the corner radius for the first image, you remove it, and then you add it back. Same thing for 2023 year as well. This was most about this demo. Let's get back to the presentation. The sample code which I shown is available on GitHub. You can see the code after the presentation as well. So demos are great. We show samples, demo looks fine. But what if you want to scale the SDUI to production? Let's talk about scaling up. As I mentioned earlier, there are few open source libraries available for SDUI. But building your own gives you more confidence and control, because your own product will have different use cases than a different product. So if you match it up closely with your design system and get your designers involved as well, the app will always look and just feel right. Share a JSON schema of what your SDUI library can handle with the backend team. This helps them to build UIs which your app can render correctly. LLM tools can also generate the layouts easily with the given schemas. Adding versioning support to your schemas will keep the update seamless and smooth. This one is important, the playground, which I also shown before that as well as demo. You should provide a playground to your QAs, designers, and product team so they can try out this SDUI before shipping it directly to the production. Generally, a desktop playground environment make testing easy and show the clear error messages. KMM can also help here too, where you can use the same library which you have built for mobile on the desktop as well. When starting with SDUI in an existing project, never try to redo the whole app from scratch. Begin with areas where fast iteration really requires, like onboarding, signups, feedback form. Gradually add the SDUI to more screen components of the app as you see the success. As mentioned earlier, security is crucial too in case of SDUI as well. SDUI should only handle UI, as name suggests. Never send sensitive data like API keys or private information to UI. Use encryption for everything sent from or to server. For sensitive values, store them safely on the app side and only use them like with environment variables, as I shown in the API call demo as well. Do not send sensitive data through the SDUI. You need to keep the compatibility strong. Make sure both new and old version of SDUI libraries work together without any breakage, obviously. The server should know which app version it's talking to and sends the right data. Try to avoid the breaking changes and use fallback UI. So let's see who is using the SDUI in real world. Reddit. They use SDUI for their feed screens. Netflix have an app called Tadam. They deliver content across mobile, web, and TV using SDUI. Airbnb. They use SDUI to build its listing screen across multi-platforms. Not just these big companies, there are a few other companies like Yelp, Lyft, Yandex, Delivery Hero, RappiPay. They also use SDUI to reduce the WebView usage and improve performance. So the future of SDUI is super smart and adaptive. We will see AI-powered apps and adjustments in real time for every user. Imagine UIs where they will get hyper-personalized and everything will feel seamless. Whether you are on phone, web, or desktop, the tools like Compose Multiplatform getting better. More teams may adapt SDUI. Yeah, AI. How we can forget AI in 2025. If SDUI is the engine, AI can be the driver. Instead of the fixed UI for every user, server can create hyper-personalized UI for every user of your app. The AI will decide the UI based on user information. For an example, if the user is an old grandma, then AI will create the SDUI JSON with bigger icons and more padding so they can easily use your app. Another example, if the user is a teenage girl, the UI can be more glittery and shiny. Again, it depends what they like. These are very basic examples. But if we plug AI with SDUI, then the sky is the limit. Here is the quick recap. We have discussed switching from WebViews to SDUI with KMM and CMP as well. It gives you agile, secure, and beautiful native-looking apps. WebViews have big downsides, but SDUI fix many of them. Now it's the perfect time to make your app future-ready. With this all, I will say thank you so much for your time today. If you like to dive deeper, want to explore more story, I have created a blog for you, which is a journey-based blog, and it's in Japanese and in English as well. Hope you have enjoyed the talk. Feel free to reach out if you have any questions. Thank you.